Hi guys. So in class today we went over the area of triangles and improper fractions rather quickly. So I just wanted to give you this little video in case you had to refer back to it while doing your homework. So I was telling you that the formula for finding an area of a triangle, you use the area equals 1/2 times the base times the height. Let's look what that looks like. I have a right triangle that looks like this. And let's say that the base is 4 and the height is 5. If the base is 4 and the height is 5, how do we find out how big this triangle is, how much area it covers? Using our formula, we would see that the area would equal 1/2 times the base, which is 4, times the height. 1/2 times 4 times 5. 1/2 times 4 is 2, and 2 times 5 equals 10. So the area of that triangle, let's say those were 4 inches, would be 10 square inches, would be 10. The interesting thing about that is you can see why that works. If I draw some little dotted lines like this, if we had expanded this triangle and made it into a square, and we found the area of the square, if this was 5 and this was 4, you remember that the area of the square is just not a square, this would be a rectangle. The area of this rectangle would be 4 times 5, which would be 20, but we only want half when we are finding the area of a triangle. So half of 20 is 10, and that's why the area of a triangle is 1/2 times the base times the height. There is a tricky thing though when you're doing this. You have to be careful about triangles that look like this, that are not right triangles. If you see a triangle that looks like this, let's say the base of this one is 10, on this side is 8, and this side is 6. Remember, it's the area equals 1/2 the base times height. The base of this triangle is 10, so it would be 1/2 times 10. But here's the tricky part. What is the height? The height of this triangle, some might think it would be 6, but that is actually not the height of the triangle. The height of the triangle is the length of the line that is perpendicular to the base, the line that hits the base at a right angle, right at a corner. This line right here does not hit the base at a right triangle, so it cannot be the height. We need to know how far it is from the base of the triangle to the very height of the triangle in a straight line. So that's where you need to use this as the height. So in this triangle, let's say that height is 7. So it would be 1/2 times the base, which was 10, times the height, which is 7. 1/2 of 10 is 5, and 5 times 7 is 35. And if these are again in inches, then the area of this rectangle would be 35 inches. So that's in your homework. Be very careful that you're choosing the right height. In this case, it was this outside one because that is the line that goes from the base to the very height of the triangle. That's why it's the height. But in triangles like this, let's draw another one. The height of a triangle like this, you have to look for the line that goes perpendicular from the base to the height in a straight line. So the height of this triangle would be this line right here. Not this side and not this side. With this line right here. The base is always the one on the bottom like that. So be careful when you're choosing the height. The height is sometimes can be the side of a triangle, but sometimes it's not. It's not the side of a triangle when the perpendicular line is not the side of a triangle. So that's what I want you to be very careful about when you're finding the area of a triangle, is choose the right height. The last thing we talked about in class that we went over quickly were improper fractions. And usually we see a fraction maybe like 1/2. This is a proper fraction. A proper fraction is named that when the numerator, which is the number on top, is smaller than the denominator. In this case, 1/2, 1 is smaller than 2. In an improper fraction, it is reversed. An improper fraction has the numerator, let's say 3, which is greater than the denominator, 2. 3/2 is considered improper because this number is larger than the denominator. So we need to change, we're going to learn how to change improper fractions into something called a mixed numeral. A mixed numeral is just a number that has both a whole number, like a 1, and a fraction, 1.5. 1.5 is a mixed numeral because it has both a number and a fraction. It just so happens that 1.5 is equal to 3/2. This is the mixed numeral way of writing it, and this is the improper fraction way of writing it. These two numbers represent the same. So you can see, like, if we have 3/2, if I have 3 pies and there's only 1/2 of each of these 3 pies left. Somebody ate the other half. This is 3/2, but it's also, you can see that if I put this half right here, that becomes 1, and you would still have this other, these two become 1, and you would still have this other half left. That's how you write these number of pies as a mixed numeral, 1.5, but you could also say you have 3/2 of a pie. So the way you transfer them, if you have a number, let's say 5/3, and in your book it says change 5/3 from an improper fraction into a mixed numeral. The way you do that is simply to remember that this means divided by. So 5 is in the numerator, so it goes under the division sign, and the 3 is here. 3 goes into 5 one time. 1 times 3 is 3. 5 take away 3 is 2. So you have 1 and 2/3 left over. Let me explain that a little more, because that was kind of quick. 5/3 then would equal 1 and 2/3. What that means is, if we have 5/3, 3 of those thirds, 3/3 equals 1 whole. So if we have 5/3, let's divide this into thirds. We're going to do pies again to explain this. That's roughly into thirds. Okay, so 5/3 would be 1, 2, 3, 4, 5. So 3/3 of it becomes 1. That's what this is. And you still have 2/3 left over. That's where this comes from. So 5/3, 1, 2, 3, 4, 5, is the same as 1 and 2/3. And that's how you figure it out. Here's the 1. 1 times 3 is 3. And then the remainder is 2. 2 what? It's 2/3. Well, let's try that again. Let's do it with 7. Let's do 7/4. We need to change this improper fraction into a mixed numeral. How do we do that? 7 divided by 4. 7 divided by 4. 4 goes into 7 one time. 1 times 4 is 4. And then you have a remainder of 3 left. So that means that 7/4 is equal to 1 whole plus 3/4 left over. That's how you get 1 and 3/4. If you wanted to see that in our pie formation again, we can go ahead and see. Let's start off with 7/4. We have 1, 2, 3, 4, 5, 6, 7. That's 7/4, and it is also 1 whole pie with 3/4 left over. You can even use that with when you don't want, you wouldn't be able to draw that many pies when you get into bigger numbers, but you do the same thing. So if we had 23, let's say we have 23/4, and we want to change this improper fraction, and we're not going to draw out that many pies, but you do it the same way. You take 23, divide it by 4. 4 goes into 23, 5 whole. 5 times 4 is 20. That leaves 3 left over. So 23/4 would be the same as 5 whole pieces with 3/4 left over. 23/4 is the same as 5 3/4. That's how you go from an improper fraction to a mixed numeral. But we also need to go the opposite way. We have to know how to go from a mixed numeral into an improper fraction. So 2.5, we know that that would be 2 whole pies, which is like this, and 1/2. So let's color them in. 2 whole pies plus 1/2. But we want to change it into an improper fraction. We want the numerator to be larger than the denominator. How many? We know that the denominator is going to be halves. But how many halves? How many halves are in 2 1/2? Let's count them. 1, 2, 3, 4, 5. There are 5 halves in 2 1/2. So I wanted to show you how we get that number, but I'm also going to show you a shortcut because you'll be working with larger numbers. So what you can do when you see the when you see the mixed numeral and you want to change it into an improper fraction, you can start down here. You can start with the denominator, 2, and multiply it by the whole number, which gives you 4, and then add that to the numerator, which is 1. So 2 times 2 is 4, plus 1 is 5. That's how you would get the 5. And then you keep this denominator the same. Let's try that with another number. Let's say 3 3/4. How do we change that into an improper fraction? We're going to keep the 4 the same on the bottom, but we need to know how many fourths are in 3 3/4. So you multiply the denominator times this whole number. 4 times 3 is 12. Then you add the numerator. 12 plus 3 is 15. So that's how you get 3 3/4 is the same as 15 fourths. That's how you go from a mixed numeral to an improper fraction. We're going to try one more, a little bit larger one. 12 3, let's say 12 3/5. The fifths are going to stay the same. We're going to follow that pattern. We're going to multiply the denominator by the whole number. 5 times 12 is 60. Then we're going to add 3, which is 63. So 12 3/5 equals 63 fifths. And that's how we change improper fractions, or this is how we change mixed numerals into improper fractions. And then we already showed you how to do improper fractions into mixed numerals.